In this video, we're going to review two examples of the offset function, one on a flat surface and one on a curved surface. First, I'll click on the scan, and then we'll look at it in 3D. We're going to measure the height of this number 1. I'm going to go back and add an offset function. For this, I'm just going to draw a line across what I want to measure. Just like that. And there is the profile of my offset function. You can see it's at somewhat of an angle. We have a handheld tool. You might not be perfectly perpendicular to your surface. So what we're going to do is we're going to add a level. In this case, we'll add a level on either side of this number 1 to define our 0 or our reference surface. Under Options in the right-hand side, I'm going to click Regions. And next to Leveling, we have this plus sign. I'm going to click that 2 times. And you can see it added these 2 green regions. I can adjust their size and location. And I'm just going to make sure that they're only covering the level region. I'm going to take top, my measurement region, and expand it over the raised area. And for both top and bottom, my measurement regions, I can select minimum, maximum, or average. I'll pick maximum in this case. And for bottom, I'm going to expand it over the average of my normal surface. And now you can see the offset being reported in the top right corner is the difference in height between the maximum point along my profile and the average of my normal surface. You also see the width being reported, and this is the distance in XY direction from the red dot to the blue dot. I'll give another example on this scan that shows an application for using the width result. I'm going to add another offset function, and we'll measure like this. And I'm going to configure this the same way I did before. I'm going to add a couple levels to this. We'll click Leveling here. I'm going to adjust the region just to my normal surface. I'm going to add another one over here. And in this example, I could even add a third one between my 2 peaks. Something like that. And now, maybe I want to measure the distance from peak to peak. So I'll take this bottom region, and I'm actually going to pick maximum here. We'll pick maximum here. And you can see the width now is 527 microns. And that's the distance from peak to peak. So even though this says bottom, you can still pick minimum, maximum, or average for either function. And the difference in height between peaks is about 4 micron. Now I'm going to go back to Explore, and we're going to go over an example with a curved surface. I'll click this scan here. And let's look at it in 3D. I'll go back to the scan, and we're just going to add an offset tool. We're going to configure this exactly the same way as we did with the other function, with the flat surface. And I'm going to add one level region right here between these 2 raised features. Just like that. And now you can really see the curvature of this surface. You can see the 0 on this graph is drawing a straight line through my curve. But in this scenario, I would actually want my 0 to follow the curvature and be along the edge of the part. So we also have this option under Leveling for order. By default, it's fitting a first order polynomial function, which is just a straight line. But if you're looking at a curved surface, you might want to fit a more complex function. So I'm going to increase the order to 2. And you'll see it just took my profile and fit the curve instead of a straight line through it. And I'll configure this the same way as I did with the flat surface. So if you're looking at a curved surface, you might just have the one added step of checking the level order of the function to fit your level region. The order goes up to level 4, so you can handle some even more complexity than just a cylinder. And then we can just wrap this up with a PDF report.